Assalamu alaikum wa rahmatullahi wa barakatuh. So today we will start our lecture 23. In this lecture we will start our new chapter, chapter 4. Chapter 4, which is about the continuous random variables. As we have seen in the previous chapter, we worked on the discrete random variables, and in the discrete random variables we have seen that the range of that random variable is defined over a fixed steps. But in the continuous random variables, that would not be a fixed steps, but that would be a range. That would be a continuous set of numbers. That would be a continuous set of numbers. And what is a continuous set of numbers? Sometimes referred to as intervals. Sometimes referred to as interval, and that contains all of the real numbers between two limits. So that's what we can see, that if we take two numbers, so we can always have a number that exists in between them, so that can go infinitely. So that we can say that is the interval, and that is the continuous number or continuous set of numbers. So the examples include maybe some, we can write it as time, the arrival time of particle, t, the arrival time of particle in certain experiment, arrival time of a particle. So that can be written as st, which is equal to t, such that t is less than infinity and greater than or equal to 0. So that limit could be any number, that doesn't matter, but that is it simply means that it must be a continuous range, and a continuous set of number, and we must have we can have the numbers in between in any set. Means if we take 0 or 1 as a range, so we can have in between another number, say 0.5. Again we can have 0.5 and 1, and we take maybe some other number 0.75, whatever. So similarly that we can go infinitely, so that means that is a continuous, and this is how we can define the range of a certain continuous random variable. Similarly, of measuring voltage across a resistor, varying voltage across a resistor. So that would be simply SV, that is V, such that given that V is less than infinity, greater than minus infinity. Again, this is a range, so we can have any numbers defined. So we call this T, V, etc. or the continuous random variables, are defined as the continuous random variables. So a distinguishing feature of the feature of the models of continuous random variable is that the probability of each individual outcome is 0. So what does it mean? That it simply means that for a continuous random variable, we cannot find the probability at a exact point, just like we have done in the for the discrete random variables. So if we have the range, so for example, if we define the range of time, say t is less than 5, greater than or equal to 2. So if we just any range, so if we want to say what's the probability of if it is a continuous random variable, so if what is the probability of 2.1, so we cannot find any value here. Okay, so that's that would be 0. The probability would be 0 at this point. So remember this thing, that continuous random variables are not defined for fixed points. So that can be understood by another example. Let's it simply means that if we observe the teacher to coming the class, observe the teacher coming for class, and we always see that a teacher arrives between 8:55 a.m. to 9:05. Yeah. So the teacher take this interval to reach any time in the class. So what happens that if we take t minutes, if we say that t minutes relative to 9 o'clock, because 9 o'clock, then it simply means that the teacher can arrive between so range of t, in other words, would be then t is given that t is less than or equal to 5, greater than or equal to -5. So plus minus 5 minutes after 9 o'clock, so teacher can arrive any time in the class. So that is the range of this thing. But what happens if we narrow down this time to, say, if we say that the teacher arrives between 8:59 and 9:01. So now what is the range? St would be simply t relative to 9 o'clock. So that would be t is greater than 1 minus 1. So similarly, we can reduce this time further if we want to make it, suppose we want to make it more precise, but say that if we say that the teacher arrives 8:59 30 seconds to 9:00 seconds. So what's the now the range? What's the now range of this thing is? This time interval is t is less than or equal to 0.5 minutes, greater than or equal to minus 0.5. Now if we just imagine what's happening, why we have done this. So here we have the range of means approximately 10 minutes window for the teacher to arrive. Here we have the 2 minutes window, and here we have the approximately 1 minute window. Now as we are reducing the time window, so what we can observe is that it's very difficult to say that the teacher will arrive within this time interval. So means probability of getting my the exact result would be reduced. Even if we could make it more precise, and we say that the teacher will arrive exactly at 9 am sharp. So that is quite difficult to find out this probability. The probability of coming of the teacher to the class exactly at 9:00 am would be very small, would be very small, so small that we can say that that tends to 0. So that's why probability of getting any number in the range, in the interval of a continuous random variable would be 0. So we can say that continuous random variable is that the amount of probability, for the continuous random variable, the amount of probability in an interval gets smaller and smaller as the interval shrinks. So the interval, as the interval shrinks, that would be very difficult to find out the probability of that random variable. So to further going to finalize the continuous random variables, so we have, just like in the discrete random variables, we started with the probability mass function, and then we figured out how to find the cumulative distribution function, and then how we can find the probabilities from PMF and CDF. So it's very convenient for the continuous random variable to start working from the cumulative distribution function. So as we discussed CDF, the cumulative distribution function, in the previous chapter, cumulative. So we have said that the CDF is a function that is defined for both discrete and continuous random variable. So basic definition of a continuous random variable: the CDF of a continuous random variable is of a continuous random variable x is, we can see this relation exactly the same as we have seen for the discrete random variable. So the properties of this this continuous random variable, this CDF of continuous random variable, are the same. So the first one, it says that so here it is defined in book as theorem 4.1. So the first part says that means the same, that it starts from the 0. B part says that at positive infinity it reaches 1. So as we know that it starts from 0 and ends at 1. And the third property says that probability of a interval can be easily find out by CDF value of, say, probability at second point minus CDF at first point. So that will give me the probability over this range. So obviously remember that the continuous random variable, the CDF of continuous random variable is also a continuous function. CDF of continuous random variable, is a continuous function. And obviously it's a non-decreasing function. It's a non-decreasing function. Non-decreasing function. So it's a increasing function, in other words, so it never goes down. Let's look at the example. So let's copy it from the book. So it is a quiz 4.2. It says the cumulative distribution function of a random variable y is this. Sketch the CDF of y and calculate the following probabilities. So sketching is again an easy task. So first we will sketch it. So here it would be y. So on this axis we will have the CDF of y. So the range is from 0, 1, 2, 3, 4, from 0 to 4. So it is 0 before 0. So it is 0 before 0, and from 0 it is we can from 0 to 4 it is defined as y over 4. So at 0 it would be 0, and at y is equal to 1 it would be 1 by 4. Say here it is 1 by 4, it is 2 by 4, it is 3 by 4, and it is 4 by 4, which is 1. So at 1 it is 1 by 4, at 2 it is 2 by 4, and at 3 it is 3 by 4, and 4 it is 1. So it means it will be a continuous function like this, and then it stays at 1 because it says that 1 for y is greater than 4. So that was the sketching of this. Now we will find these probabilities. Y is less than or equal to -1. So y is less than or equal to -1. So it simply means that we have to look at the definition of this CDF. So what's the definition of CDF? Probability of this is at less 1, or we can say that Fy of -1. So if we look at -1, it is 0, straightforward. So at f this is equal to 0. B part, it says that probability y is less than or equal to 1. So we can simply find out by Fy of 1. So Fy of 1 is defined here. We can see that at Fy is equal to 1, it is simply 1 by 4. C part says that probability of y in the range of 2 and 3. So we know that we can write it as Fy of 3 minus Fy of 2. So Fy of 3 is 3 by 4 minus 2 by 4. So that would be simply a 1 by 4. And it says that probability of y is greater than 1.5. So again, remember, we have to put it in the proper relation, because Fy of y is defined as probability of y is less than or equal to y. So we have to put this relation in this form. So we can use the complement law that we have studied in the first chapter. 1 minus probability of y is less than or equal to 1.5. Now that would be simply of 1 minus Fy of 1.5. Now if you look at this graph, it is not quite visible how to get this 1.5, but if we look at this function here, So we know that 1.5 lies between this interval, and in this interval this CDF is defined as y over 4. So we can put the value of 1.5 here, 1.5 by 4 here. So that would be our 1.5 by 4. Now just solve it, and we will get is 5 by 8. So we have seen that how simple it is to have the CDF of a certain continuous random variable, and how we can easily find out the probabilities at any point defined between the intervals. So next we have the probability density function. Probability density function, or in short form we write it as PDF, or sometimes small letters PDF. So the PDF is defined as from the CDF, because if we look at the CDF, that the slope that has the slope, and the slope of the CDF contains the most interesting information about a continuous random variable. So what it simply means that if we know from our basic calculus that to find the slope of any function, we just have to differentiate that function accordingly, so that we will get the slope of that function. So we can formally define this PDF then as the PDF of a continuous random variable x. Variable x is write it with small f sub x of x equal to t derivative of CDF with respect to x. So that is simply easy to find out how we can differentiation is a quite simple thing. So we can find out the derivative of a CDF to find out the probability density function for the continuous random variable. So just like for the discrete random variables, we had the PMF, probability mass function. For the continuous random variables, we will be having the probability density function. So the another reason the PDF is most useful probability model. Most useful probability model because it plays a key role in calculating the expected value of a continuous random variable. So it means that it will give us the direct method to find out the expected value that we have calculated for the discrete random variables. So the there are again some properties of a continuous random variable which are defined here as a theorem. They are defined as the theorem 4.2. So the first property says that the PDF is, because it's a probability model, so it will always be greater than or equal to 0 for all x. That's the simple relation. And second part says that if we have the PDF, so we can find the CDF simply integrating from minus infinity to x. Remember this range minus infinity to x because of this x is less than equal to x. So that is actually from that starts from minus infinity and less than equal to x. So that's why we have chosen this limit x. So that would be the u is the dummy variable of integration. Now we can find out CDF from the PDF also. So the third property says that if we integrate the the PDF over the range of minus infinity to infinity, that will give me the 1, because that will include the complete sample space or the range of the random variable that we have defined. So that if it means integrate it over the range, so that would obviously give me the 1. Similarly, we can have this defined as theorem 4.3. So but we can write it here as probability of if we have the range x2 x1. So to find out if it means from the CDF, that was quite easy to find out the CDF at x2 and minus CDF x1. But for this here we just need to integrate it over the interval if we are using the PDF to find out the probability between this range. So we will stop here and we'll continue in our next lecture. Stay blessed. Assalamu alaikum wa rahmatullahi wa barakatuh.